All right, to decide if a molecule is polar or nonpolar, you need to consider three things. First, you need to consider whether the molecule has any polar bonds. Secondly, you need to consider the shape of the molecule. Mostly you're trying to decide, is my molecule symmetrical or asymmetrical when it comes to the polarity in the bonds. And then three, are there any lone pairs on my molecule? So let's look at a molecule of water to walk through these three factors and decide if the molecule is polar or not. First thing you want to look at, are there any polar bonds? Okay, so you got a bond between oxygen and hydrogen, two of them actually. And remember, to decide if a bond, an individual bond, is polar or nonpolar, you look at the difference in electronegativity. And I've got the chart right down here. So if you look at hydrogen and oxygen, it's a difference of 1.4, which means these bonds are polar, okay? And if the atom that's more electronegative, higher electronegativity, you're going to put a partial negative on that atom. The atoms that have a lower electronegativity number off the chart, you would put a partial positive on them, right? And then what you can do is you can draw on these little arrows that point towards the more electronegative atom in your bond. All right, so we've got two little arrows, one for each bond, pointing both towards oxygen. You could honestly draw an overall arrow like this, pointing from south towards north. Okay, which is going to indicate that this north side of the molecule, where the lone pairs are, where the partial negative on the oxygen is, that is a very negative region of the molecule. Okay, so there's a separation of charge here, a partial one, which is why we draw these signs in. And overall, because we have this one overarching dipole, we can say the molecule is not symmetrical, and therefore it is a polar molecule. Okay, so water is a polar molecule overall. Let's consider two other examples, though, in case we still don't fully understand. All right, let's look at HCN, hydrogen cyanide, right here. So we've got two different kinds of bonds here. We've got a carbon bonded to hydrogen, and we have a carbon triple bonded to nitrogen, but that's just one kind of bond, a carbon-nitrogen bond. So carbon bonded to hydrogen, we need to decide, is that a polar bond or a nonpolar bond? So carbon has a value of 2.5, hydrogen 2.1, so the difference there is a value of 0.4, which means this bond right here is not polar. Okay, but carbon bonded to nitrogen, this bond right here, the electronegativity difference is 2.5 to 3.0. That's a difference of 0.5, which means this carbon-nitrogen bond is polar. And since nitrogen has the higher value on the chart, remember that we can put a partial negative on the nitrogen and a partial positive on the carbon. Now, the reason I'm not putting this partial positive or partial negative sign on the hydrogen is because this bond is not polar. Okay, there's no separation of charge, so we don't put the partial positive or partial negative. All right, so we do have polar bonds. Secondly, we want to say, is our molecule symmetrical? And just by looking at it, you can tell it is not symmetrical. Okay, we have one arrow that we can draw in. When I say arrow, I mean a dipole towards the nitrogen. We also have a lone pair, so we know this right here is where all the electron density in the molecule sits. So this is definitely a polar molecule. All right, let's think of one more example, though, just to drive it home. Carbon dioxide. So the first thing I want to do is assess, do I have any polar bonds? Well, the only kind of bond I have is carbon bonded to oxygen. So the electronegativity difference between carbon and oxygen is 1. So that means both of these bonds are polar. So we have polar bonds in the molecule. And if we're going to draw in our partial positive, partial negative sign, the oxygen is higher in electronegativity, so we'd put partial negative on the oxygen, partial positive on the carbon. Now, if we draw in our dipoles, we have to draw it always pointing towards the more electronegative atom, okay? So we have to draw from the carbon towards the oxygen, but we also have an oxygen on the right side. So what you end up with is two dipole arrows that are pointing opposite directions, okay? So we have polar bonds. We drew in our dipoles. Remember, we have to consider the shape. Is this molecule symmetrical? And it is. If you draw a line down the middle, you got a plane of symmetry. Both halves of the molecule are mirror images, okay? They're the same. So we've got symmetry here, which means overall we have no net polarity. What this means is that these dipoles here, they cancel out because they're pointing opposite directions, right? I hope that was helpful. And that's how you decide if a molecule is polar or nonpolar.